Hey everyone, welcome back. In the last video, we spoke about level order traversal. In this video, let's talk about zigzag level order traversal. For this tree here, zigzag level order traversal would look like this, and the output would look like this. At level 0, we have only one node, and the output is 1. At level 1, we have two nodes. We process from right to left. So node 3 is processed first and then node 2. So the output is 3, 2. At level 1, we go from left to right. So node 4 is processed first and then 5 and 6. So the output is 4, 5 and 6. At level 3, we again go from right to left. So the output is 10, 9, 8 and 7. Now to do the zigzag level order traversal, we can use two stacks. Stack S1 can be used to process nodes from left to right, and stack S2 can be used to process nodes from right to left. A stack, as you know, is a last in first out data structure. To process nodes from left to right, we must have first pushed the nodes from right to left in stack S1. Similarly, to process the nodes from right to left, we must push the nodes from left to right in stack S2. Now let's see how this works here. Initially, we add the root node to stack S1. And now we shall begin the zigzag level order traversal. Stack S1 is not empty, so we pop the node from stack S1 and assign it to a node called current. So we process the node current first, and now we shall add the children of node current to stack S2. Like I said before, in stack S2, we push the nodes from left to right. So current.left node 2 is pushed first, and then current.right node 3 is pushed next. So this ends the processing of level 0. Now we start processing from stack S2. So we pop the node from the top of the stack, and current is assigned the reference to node 3. So we process this node. Since we are in a new level, so we create a new list and add 3 to the output. Now we'll add the children of node current to stack S1. Since we are adding to stack S1, we push from right to left. So we add node 6 first and then node 5. Now again we'll pop the node from stack S2 because stack S2 is not empty yet. So current is assigned the reference to node 2. So we process this node, and now current does not have a right child, so we'll skip it, and we'll add the left child, node 4, to stack S1. So this ends the processing of level 1. Now stack S2 is empty, so we start processing from stack S1. So we pop the node from the top of the stack, and current is assigned the reference to node 4. So we shall process this node, add it to a new list. Now we want to add the children of node current to stack S2. Because we are adding to stack S2, we'll add from left to right. So node 7 is added first and then node 8. Now we again pop the node from the top of the stack of stack S1. So current is assigned the reference node 5. So we shall process this node. Current does not have a left or a right child, so we can move on. Stack S1 is still not empty, so we pop the node from the top of the stack, and current is assigned the reference to node 6. So we process this node, add it to the output. Now current has a left child and a right child. So first we'll add the left child to stack S2 and then the right child. And this ends the processing of level 2. Now stack S1 is empty, so we'll start processing from stack S2. So we'll again pop the node at the top of the stack. So current is assigned the reference to node 10. We'll process this node, add it to a new list. Now 10 does not have a left child or a right child, so we can move on. Again, we'll pop the node at the top of the stack. So current is assigned the reference to node 9. We'll process this node. Now node 9 does not have a left child or a right child, so we can move on. We'll again pop the node at the top of the stack. So current is assigned the reference node 8. We'll process this node. Now 8 does not have a left child or a right child, so we'll again pop the node And now we'll process this node 7. 7 also does not have a left child or a right child. Now stack S1 is empty and stack S2 is empty. So this ends the zigzag level order processing. Now with this understanding, let us try to code. Here the written type is a list of integer. So let's create that and name it output. We'll use an array list. If root is null, then we don't need to do any processing. So we'll return the empty list. We'll need two stacks. So stack of tree node S1 new stack and stack of tree node S2 new stack. Now we'll add the root node to stack S1. So S1 dot push root. Now let's begin the zigzag level order traversal. While S1 is not empty or stack S2 is not empty, we want to create individual lists for each level. So list of integer list. Now we'll process each stack. So while stack S1 is not empty, so we pop the node from the top of the stack. So tree node current is S1.pop. We process this node, so we'll add it to the output list.add current.value. Now we want to add the children of node current to stack S2. So we'll add from left to right. So if current.left is not equal to null, we'll add S2.push current.left. Similarly, if current.right is not equal to null, then S2.push current.right. Now at the end of this while loop, we want to add, so this list will have one level, nodes of one level. So we want to add that to the final output. But there can be a case where this stack itself is empty and we are not adding anything to the list. So we can check if list.size, if it is greater than 0, then we want to add it to the main list. Output.add list. We want to clear this list so that we can use it again. Here we have to be careful because this list is a reference. We want to create a copy of it. So we use array list, new array list, and then pass this list as argument. So this will create a new copy of the list. Because this list is changing, we don't want to point that changing list in the output. Now I'll show at the end if we don't use this deep copy, our output would be empty. Now we'll start processing list stack S2. If stack S2 is empty, while this is not empty, so we again do the same thing as here for stack S1. We pop the node. We'll process this list.add current.value. Now while adding to stack S1, we process in the reverse order, that is from right to left. So we'll check if current.right is not equal to null. We add S1.push current.right. Similarly, if current.left is not equal to null, we can do S1.push current.left. So at the end of it, we want to add this list to the output. So it's the same thing. I'll copy paste it. So we want to clear it again so that it will be used in the next while loop. At the end of it, I'll return the main list of list, which is the output. I'll submit this. It seems to work fine. Now I'll remove this and let's try to run this. So the output list is empty. So that's the reason we want to create a new array list instead of a reference to the same list. So I'll revert it back. And now I'll submit this code. So it seems to work fine. So thank you very much for watching this video. If you enjoyed it, please hit the like button and do subscribe